This would be part 2 of 2.2.2. So, question 253, the big race, heat 2. In the second heat, Elizabeth, Kay, and Hannah raced down the track. They knew the winner would compete against the other heat winners in the final race. So, when the line representing Kay's race is graphed, the equation is f of x equals 3x, 2 over 3x plus 1. What was her speed in meters per second? Did she get a head start? So again, here, remember, we're looking, f of x is the same thing as y. So we're looking at y, or f of x equals 2/3 x plus 1. And remember, it's always in the same form of y equals mx plus b in this case. They are different forms for writing equations of lines. We're starting off with the easiest one, all right? So here, m is 2 over 3 meters per second, right? Meters per second. And then b is 1. So here we can see clearly that she got her speed is 2 over 3 meters per second, right? So K's speed is 2/3 meters per second. And she got a head start of 1 meter. That's our B value right there. All right. Now let's look at Elizabeth's race as given by the equation. F of x equals 12 over 16 times x plus 4. Who is riding faster, Elizabeth or Kay, and how do you know? So if you do notice here, like they are different, they look like different fractions. So we have 12 over 16, all right, and that's Elizabeth, and then Kay again, which was 2 over 3. So we're trying to see which of these two speeds is greater, all right? So pretty much K's speed, if you change that to a decimal, again, you can always use a calculator, punch it in. You're going to notice that they're going at 0.667 meters per 1 second. All right. Now, if we plug this in, we actually simplify this, the Elizabeth's equation. Both of these are even, so that means that we can divide both of these by 2. And actually, both of these have a factor of 4, so we can divide both of them by 4. So let's do that to simplify the equation. So that gives us 3 over 4, which is pretty much 3/4 or 3/4 is 75, so 0.75. 75 meters per 1 second. So who's riding faster? The person that's going 0.75 meters per second or the person that's going 0.67 meters per second? So in this case, we're going to say Elizabeth is riding faster. Faster at 0.75 meters per second. And K is going at 0.67 meters per second. All right, I am rounding right there. I did round to the third decimal here. So let's do the same thing here. Okay, and then just as she started pedaling, Hannah's shoelace came untied. Being careful not to get her shoelace tangled in the pedal, she rode slowly. Hannah's race is represented in the table right there below. At what unit rate was she riding? So let's try to figure out how fast is she going. So to determine that, we know this is a time in seconds, right? So as we did yesterday, we can pretty much pick two values on the table to figure out the rates. All right, so remember the time is our x's and then the y is our meters or distance. And then to figure out the rate, remember it's the change in y over the change in x, which in this case would be, let's do it on this side. So delta y over delta x. So let's start off with the y's first. So we're going from 10 to 14. So from 10 minus 14, and then 14 minus 28. 14 minus 28. That gives us -4 on top, divided by -14 at the bottom. A negative divided by a negative is a positive, and then both of these have a factor of 2, so divide both by 2. So that gives us 2/7 meters per second. So again, Hannah is going at a rate of 2/7 meters per second. All right. And then to entertain the crowd, a clown rode a tricycle in the race. His race can be modeled by the function f of x equals 20 minus x. Without graphing or making a table, fully describes the clown's ride. So again, even though this is in a different order, right? You notice that the x is in the second spot here. You want to be careful because the x is still next to the rate. So here, identify M and B, right? Let's first rewrite this. We're going to rewrite it in the order we've been looking at. So we're going to say f of x equals, the x's go first, so that would be negative x. And then since there's no sign in front of the 20, it's always going to be positive. So plus 20. So here, technically, we have a 1 in front of the x, not a 0, always a 1 if you see the variable by itself. So our m is equal to negative 1, and our b is equal to positive 20. So remember, when you guys look at a negative number, it is a change in direction. So here, we know that the clown is going backwards 1 meter every second, and then it started off at 20, at the 20-meter line, which was pretty much the finish line. So we can say that the clown was riding backwards from the finish line at a rate of 1 meter per second.